Now, let's talk about Newton's first law of motion. So Newton's first law of motion is usually used to describe a situation where there is no net force acting on an object. Okay, so if there's no net force acting on an object, use Newton's first law of motion. So let's try to understand what Newton's first law of motion is about. An object at rest will remain at rest. An object that is moving will continue to move. Okay, but if it's continue to move, it has to move with constant velocity or uniform velocity in a straight line. Okay, so there's two parts over here. First part is at rest, remain at rest. If it's moving, it will continue to move, but with uniform velocity in a straight line. So two situations that we are going to analyze. And this is what happens if there's no net force acting on an object. Okay, so as I said just now, Newton's first law is for situation where there is no net force. Okay, so let's try to analyze this statement in greater depth, and we'll use a statement that I use in the chapter 4 overview to analyze the statement. I mentioned in the chapter 4 overview videos that this sentence here, net force changes the state of motion of an object, is a very important sentence, and it encapsulates all the things that we are going to learn in chapter 4. Okay, all the things that we learned in chapter 4 can be binded onto this statement over here. And if you're not sure what I'm talking about, please watch back the chapter 4 overview video. But now I'm going to use this statement here to explain Newton's first law of motion. So we learned that net force changes the state of motion of an object. State of motion, as I mentioned in the website, it's described by velocity. Okay, so I say the state of motion of the object is it is moving with 5 meters per second to the right. I use velocity to describe the state of motion of an object. If an object is not moving, then the state of motion is 0 meters per second. If the object is dropping downwards and at that specific moment is dropping at 5 meters per second, then the state of motion is 5 meters per second downwards. That is its state of motion. So if the state of motion changes, then that means the velocity changes. So if it speeds up or it slows down or it changes direction, that means it changed the state of motion. So if you see things speed up or slow down, or you see things changes direction, because changes direction is also change of state of motion, then that means there is net force acting on an object. Okay, if there's net force, then you can observe things like speed up, slow down, or change direction. So that's the statement we learned in the overview. Now let's flip the sentence, because the Newton's first law here is on when there is no net force acting on an object, but this one is when there is net force. So let's flip the sentence. So if there is no net force, what will happen? Net force changes the state of motion. So if there is no net force, then the state of motion won't be changed. If the state of motion won't be changed, there is no change in the state of motion. So you have no net force, you have no change in the state of motion. Because net force is the cause. Okay, net force causes the change of state of motion. So if there's no net force, then you will not have any change in state of motion. Okay, I'm flipping a sentence right now. Okay, so this is the idea behind Newton's first law. And when we say no net force, it means the summation of forces is equal to 0. So let's say if you have no forces acting on an object, then of course the sum of F is equal to 0 because there's no force to be added out. Or let's say if there's two forces acting, one upwards, one downwards, but if you sum down equals 0, that means the magnitude of the upward force is cancelling the magnitude of the downward force. So they cancel each other out, therefore you have no net force. Or if you have more than two, let's say you have 4 forces pointing different direction, then if you sum down equals 0, then that means the component pointing to the left will cancel the component pointing to the right. And the component pointing outwards will cancel the component pointing downwards. That's the idea of 0 net force. But of course, when we talk about net force, right, because this is in vector, we can split it into components actually. So actually, when we say no net force, right, it's either there's no net force in the x direction, sum of x equal to 0, or there's no net force in the y direction, which is sum of fy equal to 0. Okay, so if sum of fx is equal to 0, then in that dimension, in that x dimension, there is no net force acting on an object. So you should expect no change in state of motion in the x dimension. Okay, and of course, if sum of fy is equal to 0, then that means there is no net force in the y dimension. a y dimension, that means up and down cancel out, then that means there's no change in state of motion in the y dimension. That means in the y dimension, your object in the up-down motion, it has to be at rest, or it has to be constant velocity. No change in the up-down motion. No change in the up-down velocity. Okay. So no change in state of motion means no change in velocity, because velocity is used to describe state of motion. So there are two scenarios, as I mentioned just now in the sentence. There are two scenarios which there is no change in velocity. First is if your velocity is equal to 0. If initially an object is at rest, then initially the velocity is equal to 0. Then what will happen if there's no change in velocity? Initially 0, after some time, remain at 0. So if an object is at rest, it will remain at rest. And this is a situation of static equilibrium. And it's mentioned over here, an object at rest will remain at rest. And this is static equilibrium. Okay, so that's the first situation. The second situation of no change in velocity is if your initial velocity is not 0. If initially you are already moving. So let's say if we see an object and that object is moving at 5 meters per second to the right. It is already moving already. But you know that if there is no net force happening, then it will continue to remain at that same speed in the same direction. Okay, so if initially it's already not 0, then you continue to move with that velocity. And this is described in this statement over here. An object that is moving will continue to move with uniform velocity in a straight line. So it will continue to move with constant velocity. Then why do they say in a straight line? It's because velocity here consists of magnitude and direction, because it's a vector quantity. So vector quantity has magnitude, has direction. So constant magnitude of velocity means constant speed. So same speed. Constant direction of velocity means initially to the right, after that it will continue to the right. Initially 45 degree above x-axis, after some time it will also be 45 degree above x-axis. So you travel in a straight line because you cannot change direction of motion. If you turn, if you bend, if you rotate, then it's no longer first law anymore, because there is net force, because there is change of velocity. Okay, so this kind of situation where an object is moving and continue to move but with constant velocity, we call it dynamic equilibrium. So there are two cases here, static equilibrium and dynamic equilibrium, and this happens if your net force is equals to 0. So to sum up the things, Newton's first law is used to describe a situation when there is no net force. So when there is no net force, we know that there will be no change in velocity. So no change in velocity is composing of magnitude and direction. So no change in magnitude should be constant speed. No change in direction means by moving in a straight line. If it's initially at rest, then you continue to remain at rest.